Good morning, dear students. My name is Ferhan Mazher, and today is 10th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O level physics, and the code of the subject is 5054. And today we have set our hearts to solve ATP paper. And today we have selected May June 2013 for one paper. This paper 4 belongs from the zone 1 or the variant 1. The time allowed for this paper is 1 hour. So let's start this paper. So on your screen, the paper is showing up. It's 2013, May, June for 1. And here comes the first question. A student investigates the time taken for a light paper cup to fall to the floor. The student holds one paper cup as shown in the figure 1.1. The student drops the cup and measures the time t for it to fall to the floor. He will drop it and they will note down how much time it takes to drop to the floor. And you can see the student is holding the cup. The same student is holding the stopwatch. The student repeats the experiment and obtains the following 5 values for the t measured in the seconds. So 1.19, 1.00, 0.93, 1.03, 1.08. Calculate the t average, the average value for the t. Give your answer to 2 decimal places. So t average will be equals to, we will add these 5 values and then we will divide it with the 5. So you can see here I have added them. Whatever is the answer, I will divide that answer with the 5. You get 1.046. So the t average will be 1.05 seconds. So let's check. 1.05 seconds is the right answer, sir. Okay. Then their question is the student records his value for the t average to more than 2 decimal places. So just why 2 decimal places is more suitable in this case. If you look at your raw data, the time given is all the values in the raw data. They are correct up to 2 decimal places. And they have a large variation between them. So that's why it is a sensible thing to take the t average up to 2 decimal places. So let me show you my written answer. It says raw data is up to 2 decimal places. There is large variation in the data. So let's have a look at the marking scheme. Large difference in the raw data. Reaction time has large variation. Okay. So the student records his value of, okay. The student finds it difficult to drop the cup and measure the time. Suggest how 2 students work together can measure t more accurately. So it's a very because they have used only one student, he drops the cup and he also notes down the time of flight, time of the fall. It will be better if you use 2 students. One student will drop the cup, the other student will hold the stopwatch. He will note down the time with the help of the stopwatch of the fall, and then it will be more accurate. And they can repeat the experiment and then take the average of the time taken. So let me show you my answer. One student drops the cup, second student note time of the fall by using a stopwatch. They can repeat the experiment and take average value of the time. Okay, so then the next question, let me show you the marking scheme. One drops, one times. Okay, so countdown or signal explained. Okay, so when he drops the cup, he can give the signal. The one student who drops the cup and he can give a signal, like he can say start, and when the cup hits the floor, he can say stop. So by the signals, it will become more accurate. You can also write these. Okay, it is written in the marking scheme. So then what it says. Uh, okay. The student repeats the experiment with the 2 cups as shown in the figure. Now they are using 2 cups like this. The experiment is repeated for an increasing number of the cups. The results obtained are recorded in the figure 1.3, where n is the number of cups. Add to the figure 1.3 your result of t average for 1 cup. The t average for 1 cup is 1.05. You can write it here. And then they say on the figure 1.4, plot the graph of the t average on the y-axis against n. On the x-axis, start your axis t average from 0.5 second and n equals to 0. Draw the smooth curve of the best fit. So and the y-axis will start from the 0.5 second, and on the y-axis we have time, average time, And on the x-axis, we will represent the number of the cups, and it starts from the 0. So let me show you. It's a 4-mark question. I have done this. Okay. So this is that the n value is going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going up to 11. And the t average value is from 0.61 to 1.05. So you can see that I have, this is, you see on the x-axis, I have represented n number of cups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here on the y-axis, I have represented the t average in seconds. And it goes from 0.5, 0.6, 0.7, 0.8, 0.9, 1, and 1.1. Okay. So, so the first value is 1.05 at 1. At 1, it will be 1.05. That point is here. I by mistake I have put the dot here, but this dot is here basically. Okay. 1.05 is this point. 1.05 is this point. Put a dot here. So and then it is 2, 0.89 at 2, 0.89 is this point. Okay. At 3, 0.8, 0.82. At 5, you have 0.69. This is the point. And at 7, you have 0.63, this point. And at 9, it is 0.61. At 9, you have 0.61. And at 11, 0.61. So this point is not here. This point is basically here. So then I will join it with the smooth curve. This point will be from here. The smooth curve will be drawn like this. Okay. A smooth curve will be drawn from here. So mark this mistake. This 1.05 is this point. Okay. And you can draw the line of best, the smooth curve. It's nothing. It's very easy. Okay. I hope you will understand that what mistake I made. I put the dot on the wrong place. Okay. Now, he says when two quantities x and y are inversely proportional to each other, they obey the relationship their product remains constant. You multiply them, they remain constant. Use data from the graph to table to explain whether T average is inversely proportional to y. Okay, so for example, the value of for the from the, if you use the value from the, you take the value from that table. So at 2, the value is 0.89, and at 5, the value is 0.69. So when you multiply these two values, 2 multiply, this is the x, this is y. So you multiply, you get 1.78. When you multiply 5 with the 0.69, you get 3.45. So that product is not same. If the product remains constant, then you can say that these two quantities are inversely proportional to each other. But here you can see from the table I'm using the data, and their product is not constant. So as the product of the xy is not constant, so T average is not inversely proportional to n. I hope you understand. Let me show you the marking scheme. Okay. So you can see the marking scheme says the same thing. Okay, now we are going to the next part. It says use data. Okay, we are done this. It is important to drop the cup from the same height each time. Explain how the student does this without measuring the height. You see, one student who will drop the ball, who will drop the cup, he will stretch his arm horizontal. He's standing, he stretches his arm horizontal. And from that height, each time they drop the ball and drop the cup. So that is one way of doing this. So my answer is student stretch his arm horizontally, and each time cup is dropped from this level. So let's check what the marking scheme says. Sensible suggestion, for example, hold arm horizontal, stands in the same place, and use a marker in front of mirror and use images. Okay, so our answer is right. So name the physical quantity being changed by increasing the number of cups. When you change the number of cups, for example, you make the cups 2, you make the cup 3. So the body which is falling down, its weight is increasing. So that is my answer. Weight of the falling body is increasing. So let's see what the marking scheme says. Mass or weight. Okay, that increases. The student accidentally stands on one cup. Explain why it should not be used in the investigation. You see, when the student stands on a cup, the cup is a paper cup, it will collapse. And when it will collapse, its shape will change. Now, this cup cannot be used because its surface area has changed. When the surface area will change, the air resistance it will experience that will also change. So let's have a look at cup will collapse its surface area. The cup will collapse its surface area will be different from the other cups. So it cannot be used. And let's look at the market. Change surface area, air resistance. Cases will stack, will not stack. Okay. The cups will not stack. So I said, okay. So that's the reason why the last two values of the T average in the figure 1.3 are the same. If you look at that table, the last two values, you have used 9 cups or you have used 11 cups. In both the cases, now the time of fall is same. You see, and when you have put 9 cups, I think the weight has become so much heavy of those cups that the air resistance they are getting in that fall is not enough, and it's the air resistance value as compared to the weight is very small. So that's why both the weights have the same time of fall. If the air resistance is very small portion to the weight, so proportional air resistance is very small proportional to the weight, so the cups heavier than certain value all have the same time of fall. Okay, so let's check from the marking scheme. Heavier, so the air resistance has little or same effect. Small percentage change in the mass due to the uncertainty in the time and height. So heavier, so air resistance has little or same effect because the cups have now become heavy. When you have put 9 cups or 11 cups, they have become heavier. So the air resistance is having very small effect on them. Certain value all have the same time of fall. Okay, so we are going to the next question. A student investigates the behavior of the resistors. The three resistors A, B, and C are labeled 100 ohm, 150 ohm, and 220 ohm respectively. Draw the arrangement of the A, B, and C that gives the largest possible total resistance. You connect them in series. You connect them in series, and they will have the largest resistance. And then the question is calculate the resistance of this arrangement. You just add them up. So 100, 150, and 220, the total resistance will be 470 ohm. So this is how you will show these two parts. So let me show you. So our answer is right. Okay. Draw the arrangement of the A, B, and C that give the smallest possible total resistance. You arrange them in parallel to each other, and their resistance will become smallest. The combined resistance will become. So this is how you will show arrange them in parallel to each other. Series drawn in parallel. Okay. Now we have a fourth resistor is shown in the figure 2.1. The resistor color code is shown in the figure 2.2. So the brown means 1, the gray means 8, and the brown means 1. Okay. So these the first two bands gives the digits, and the last number gives the multiplier. So let me show you what I mean. You see, okay, the first two colors give the numbers, digits, and the last third one that gives the multiplier. So brown means 1, gray means, from this table I'm saying, gray means 8, multiply. The last color tell you the multiplier, 10 raised to power what? So brown means 10 raised to power 1. So 18 multiplied 10 raised to power 1, that will be 180. So the resistance will be 180 ohm. 180 ohm. So first two colors give you the digits only, multiply, and the third color gives you 10 raised to power what? Okay, it gives you the exponent of the 10. We call it multiplier. Okay, so let's go to the next question. The next question is question number. First, let's check the marking scheme. Yeah, our answer is right. So we are going to the next question. The next question is question number 3. He says, a laboratory thermometer is used to measure the temperature of oil in a test tube. The thermometer is initially at the room temperature. Figure 3.1 shows the thermometer. So state the temperature shown by the thermometer in the figure 3.1. It is 22. The reading is 22. The reading is 22. Okay, so our answer is right. 22 is the right answer. Okay. Then this says a test tube of oil is heated in a bath of very hot water for 15 minutes, as shown in the figure 3.2. Explain why the level of the oil in the test tube should be below the level of the water in the water bath. This oil in the test tube has lower level, and the water in the beaker has higher level. Why? So that the oil is heated uniformly throughout the body of the oil. Throughout the body of the oil, the heat is given uniformly. To provide the oil uniform heat from all sides. This is my answer. So let's have a look at the marking scheme. All the oil is heated, all the oil below water surface, uniform heating of the oil. Okay. Then he says a student removes the test tube from the water bath. He then places the thermometer in the oil. Describe how the reading on the thermometer changes over the next few minutes. You see, when you will put the you have taken the test tube out of the water bath, and obviously the oil is hot, and you have placed a thermometer in the in that oil. So first of all, the reading of the thermometer will go up, and after attaining a certain temperature, highest value, and then it will start coming down because the oil will start cooling down. So the temperature on the thermometer will also start dropping. So what will happen in few minutes, the thermometer reading will increase, then it will start decreasing. So let's see what the marking scheme says. Temperature rises, then falls. Okay, our answer is right. Okay, then it says, describe how the student reads the thermometer accurately. For me, reading the thermometer accurately, you see the line of sight of the observer should be perpendicular to the scale where the level of the mercury is, and it will help you to avoid the parallax error. Okay, line of sight should be perpendicular to the scale of the thermometer. Okay, so here we go. Avoid parallax error, good explanation. Read top of meniscus, align scale with the liquid column. Okay, then the question is, he says, describe. This is done. He says the second student repeats the experiment in the B using a temperature sensor instead of a thermometer. The temperature sensor is connected to a data logger. The data logger records the temperature every 0.1 second for 20 minutes on the axis shown in the figure 3.3. Sketch the shape of the graph produced by the data logger. So let me show you what kind of shape. So in 20 minutes, first the temperature will go up. At the start, the rise of temperature will be very fast, then it will be slow. And then the temperature will start falling. At the start, the temperature fall will be fast, and then it will gradually, the rate of the fall of the temperature will decrease. So it's a curve. Okay. So this is the graph you have to draw. Smooth concave curve asymptotes to above zero. So we are done with this question. Okay. So figure 4.1 shows a triangular cardboard lamina with three holes. Let me call it A hole, B hole, C hole. Describe an experiment to find the position of the center of the mass of the lamina. You may use any common laboratory equipment. Your answer must include a labeled diagram of the apparatus being used. And it's a 4-mark question. It's the last question in this paper. So let me show you. Here we go. So here is that diagram. We have shown a retort stand, and in the clamp of the retort stand, I have put a pin, and this lamina is hung through on this pin by this hole A. Then I have used a plumb line, and I have hung the plumb line coinciding with this hole. And when the plumb line becomes steady, draw a line on the lamina along this thread, then hang it with the from the hole B, and again draw this line along the plumb line, and then hang the lamina from the hole C and along the and hang the plumb line, and then draw a line along the thread of the plumb line, where those lines which you have drawn on the lamina, they will intersect. That will be the center of the mass. Okay. Hang the lamina from the hole A on a pin held in the clamp of a retort stand. When the lamina becomes steady, hang a plumb line coinciding with the nail or the pin along the thread of the lamina. Draw a line on the lamina. Repeat the same procedure by hanging from hole B and the C, where the lines drawn on the lamina intersect each other. That point will be the center of the mass of the lamina. So this is our answer. So let me show you the whole answer that's showing up on your screen. So let me show you the marking scheme. He says this is this is the, I hope you can see that. Freely suspend the lamina from the hole. Correct use of the plumb line shown on the diagram. Line marked on the lamina repeated from different holes and find where lines crosses. Alternative experiments are the balancing on a ruler can score 0.13 and 4 max. So this is the answer. And my dear students, today we have done May, June 2013 Physics 5054 4-1 paper. And this paper 4 was from the zone 1. So if you find this video interesting, informative and helpful to you, please share the link of this video onto your Facebook, onto your Twitter accounts, and onto your Instagram. Also share the link of this video with your junior students. And thank you very much everyone for watching my video and taking your time for studying physics. Have a good day. God bless you all.